Imagine for a moment, if you can, if the very genes inside people could tell this epic story.
Hmm.
Not just any story, but one about survival, about empires rising and falling, terrible wars, but also incredible resilience. That's exactly what we're digging into today. The really intricate gene pool of modern Serbians,
Yeah, it's pretty amazing, actually. Scientists have found that
yeah,
Serbia, right there in the heart of the Balkans,
which is such a historically charged region.
exactly, a real crossroads, tons of pressure, cultural mixing.
Well, its gene pool is just as diverse and layered as you'd expect from that kind of past. So this deep dive, it's going to show us not just who Serbs are now, but, how their history over millennia is literally written in their DNA.
Right. So our mission here is to unpack this really fascinating genetic story. We're aiming to uncover some, frankly, surprising facts and connections, things that will get you genuinely well-informed, give you that aha moment, but hopefully without feeling like you're drowning in data.
Yeah, keep it accessible. Exactly. So get ready. We're diving into ancient history, huge migrations, and yeah, even some modern controversies, all through this amazing lens of genetics.
Okay, so let's set the scene first. You look at Serbia on a map, and its historical role just jumps out at you.
Definitely.
It's really been this meeting point, East meets West. You had the Romans, the Byzantines, the Ottomans, the Austro-Hungarians. They all left their footprint. Their armies marched across these lands, cultures mixed.
Bloodlines, too, over centuries.
Absolutely.
And this unique spot on the map, with its mix of really isolated mountain areas, but also these open plains where people did mix more, it's basically created what you could call a living mosaic in Serbian genetics. It directly reflects that ancient and medieval past.
A living mosaic. I
Yeah.
like that.
Yeah. And it brings up a big question for us. How clearly can we actually see those big historical movements reflected in the genes today?
That is the key question. And the genetic numbers, well, they paint a pretty compelling picture. For instance, scientists have found that something like 60% of Serbian men carry a specific Y DNA haplogroup. And just to remind everyone, that's the genetic signature passed purely down the male line, father to son. Traces your paternal ancestry.
Right, thanks. It's called I2. And what's really striking is that's 60%. That's one of the highest frequencies of I2A found anywhere in the world.
Globally, yeah. It's significant.
And get this. This I2A traces way back. We're talking Balkan Paleolithic hunter-gatherers.
The original inhabitants of the region, really, living there over 10,000 years ago.
Yeah.
Way, way before farming even started there.
So that points to incredibly deep local roots, right? Long before any Slavic groups arrived on the scene.
Exactly. And then, if we look at the next layer, sort of the secondary wave, we find haplogroup R1A.
Which is more common in Slavic populations further north and east.
That's the one. It's found in about 15 to 20% of Serbian men. So that pattern strongly suggests, a real blending. The later Slavic migrations mixed with the people already there. They didn't just replace them.
Okay, so blending, not replacing. And what about the maternal side? Does that tell a similar story?
It complements it, yeah. Looking at mitochondrial DNA, which, remember, is passed only from mother-to-child studies, show lots of haplogroups H and U. And those are really typical markers for the Neolithic farmers in southeastern Europe.
Ah, the ones who brought agriculture about 8,000 years ago?
Precisely. The groups who fundamentally changed how societies worked there.
So, okay, let's try and put that genetic picture together. If we translate that data,
Yeah.
it seems pretty clear that Serbs aren't just, purely Slavic. Doesn't sound like that at all.
Not in a simple sense, no.
Their genetic fingerprint tells this more complex story, deeply Balkan-rooted from those ancient times.
Right, that I2A,
And significantly influenced by the Slavic migrations.
the R1A layer.
And maybe even carrying some subtle marks from, say, the Ottoman period interactions.
It all adds up.
It really seems to form this unique genetic blend, doesn't it? Different from people further north where R1A might dominate, or maybe even distinct from their Greek neighbors who have their own ancient tapestry.
Very distinct, yes. A unique Balkan signature.
Which then leads us straight into a really important and sometimes difficult question. What does all this genetic evidence mean for understanding identity, especially in a place like the Balkans with such a complex history?
Ah, yes. That's where it gets complicated.
Because this fascinating genetic makeup, it inevitably bumps up against, well, the politicization of genes. You see this in Serbia and honestly across a lot of the Balkans. Genetic studies have sometimes been, well, misused.
That's putting it mildly sometimes.
Yeah. Used to argue for ethnic superiority, or to back up claims to territory, or to try and prove who was there first in disputed areas like Kosovo or Bosnia.
That's absolutely right. You definitely hear some nationalist narratives cropping up, like the idea that Serbs are somehow the original Europeans. People might point to those high I2A frequencies we talked about.
Misinterpreting it.
Exactly. Misinterpreting it as proof of this unbroken line right back to the Ice Age, exclusively for them. But geneticists are really clear on this. They strongly caution against using the data that way.
Yep.
Because I2A, while it's high in Serbs, is actually widespread across the whole Balkan region. It's not exclusive to any single modern ethnic group.
So it connects people rather than dividing them, genetically speaking.
Precisely. It's a classic example of how scientific findings, if you take them out of context or twist them, can unfortunately be turned into political weapons.
And what I find really interesting here, maybe even counterintuitive for some listeners, given those narratives, is that the genetics actually seem to point towards deep shared ancestry. Shared roots between groups like Serbs, Croats, Bosniaks, even Albanians in some respects, not separation.
That's a critical point. Absolutely. The genetic data often highlights common origins more than divides.
How significant is that finding, especially when you have these strong nationalistic claims based on supposed difference?
It's hugely significant because from a purely scientific viewpoint, the answer is pretty straightforward. Your genes don't dictate your modern national identity.
Right.
That identity comes from shared culture, shared history, language, personal and collective choice. Things like that. So the fact that these groups share a lot of genetic heritage points to common deep roots, it reminds us that today's political borders often came much, much later than the genetic mixing.
So it doesn't erase national identity, but it challenges narratives of ancient, pure separation.
Exactly. It adds complexity and context. And that's why Serbian genetics isn't just scientifically fascinating. It's also, as you said, politically explosive sometimes.
Okay, let's shift gears a bit. Away from identity politics, fascinating as it is, and look at health. How does this specific Serbian gene pool offer insights into, say, population-specific health patterns?
Well, there are some really interesting findings there, too. For example, researchers have noticed a higher frequency of certain BRCA1 and BRCA2 gene mutations in specific regions of Serbia.
The ones linked to breast cancer risk.
That's right. Studying these populations has actually provided really valuable data for scientists working on understanding and fighting breast cancer globally.
And I also read something about isolated populations.
Yes, that's another key area. Some more isolated, often rural, communities in Serbia show these unique clusters of otherwise rare genetic disorders. Now, while that's challenging for the people affected, for researchers, these clusters act like natural laboratories.
How so?
Well, it makes it easier to track down the specific genetic mutations causing the disorder because the genetic background is less varied than in a big mixed city population.
Ah, I see. It narrows down the search.
Exactly. And that can seriously speed up finding treatments or maybe even preventative strategies, not just for people in Serbia, but potentially for anyone with that condition worldwide.
That's fascinating. Any other traits linked to the gene pool?
There's some emerging evidence, still early days maybe, but suggesting potentially higher resistance to things like cold or fasting conditions in some Serbian groups.
Really? Linked to ancestral adaptation, maybe. Living in tough environments.
That's the hypothesis, yes.
Yeah.
Possibly linked to adaptations from ancestors living in challenging mountain environments over long periods. Needs more research, but it's an intriguing possibility.
And the practical impact of all this health-related genetic information, it could be huge down the line, couldn't it?
Potentially, yes. These unique genetic traits and predispositions. One day, they could really inform the development of personalized medicine tailored specifically for people in southeastern Europe.
Taking their specific genetic background into account for treatment.
Exactly. It shows how genetics isn't just about ancient history or identity. It can have very real, practical health implications.
So, wrapping things up a bit, when we talk about what makes the Serbian gene pool truly unique, what's the core message?
I think what makes it so distinctive is how it tells multiple stories, all layered together all at once. You've got this story of deep, deep Balkan ancestry stretching back, over 10,000 years to those first hunter-gatherers. That's one layer.
The I2A story.
Right. Then there's the chronicle of the Slavic expansion, but crucially, as a blend, an integration, not just wiping the slate clean, it added to the mix.
Mar1A blend.
And then, layered on top of that, or woven through it, is this powerful narrative of survival. Surviving under huge empires, Roman, Byzantine, Ottoman, Austro-Hungarian, yet managing to preserve a sense of cultural and, it seems, genetic identity throughout all that pressure.
It really does sound like a gene pool that reflects that complex Balkan spirit we talked about earlier.
I think so.
Something that both unites people through shared deep history, but also, sadly, something that can be twisted or misused to try and divide them. It's a mirror, in a way.
A mirror of the region's history, definitely. Which leads us nicely to a final thought, perhaps.
Okay, let's bring it home. We started by asking, is the Serbian gene special?
And the answer?
I think it's absolutely yes. But, and this is the crucial, but it's not special because it's somehow pure or superior. That's not it at all.
No, that misses the point entirely.
It's special precisely because it proves how identity is actually this layered, incredibly complex thing. It's constantly evolving. Genes don't lie about our biological past, our ancestry, but they definitely don't always mean what people want them to mean for defining who we are today.
Well said. And maybe that leaves us with a final question for you, the listener, to mull over. Should we primarily be using genetic research to try and bolster modern political identities, to draw lines? Or should we perhaps see it as this powerful scientific reminder that really, under the skin, we're all far more connected with these incredibly deep shared roots than we often tend to think?
It's a provocative question, and definitely something worth pondering long after this deep dive finishes. Remember, what we explored today was really about how we tell our human stories, how science intersects with identity, and we really encourage you to keep exploring these complex, fascinating ideas on your own.